Let's say you are executing within a PowerShell, right? For example, during a penetration testing activity. Now, if you execute a malicious payload like this one, which loads a reverse shell within the PowerShell process, you're gonna get blocked, basically, right? So you're gonna get this thing. You're gonna get this script contains malicious content and has been blocked by your antivirus software. Now, in this context, what is going on is AMSI, Now, AMSI is the so-called Windows Antimalware Scan Interface. Recently, I did a lecture about it, and so I wanted to bring a few payloads that I showcase in the lecture. Now, the idea of AMSI is that AMSI is an interface, right? So basically, here you have your antivirus solutions, and the antivirus solutions communicate with AMSI. Now, PowerShell has an internal library that communicates with AMSI. So basically, every time you write something to PowerShell, it's going to communicate to AMSI, which is going to communicate to the antivirus. So this means that AMSI does not implement by itself the detection engine. It is just an anti-malware scan interface. It is just an interface. This means that we can bypass the interface without evading the engine. That is, we have a payload which would be triggered by the engine if the engine performs a scan. However, we break AMSI, we bypass AMSI, and so we don't even trigger the antivirus. Okay, so that's what I want to explore in this video. Now, specifically, I want to showcase this payload. Now, this is a simple payload that, by the way, does not work with modern version of AMSI. Still, I think it is useful to understand if you want to learn about AMSI bypass. It is a good starting point. Now, as you can see, this payload uses the reflection capabilities of the .NET framework in order to override the value of a particular field. Specifically here, we are extracting the AMSI utils class from the system.management.automation DLL, and we are setting the AMSI init failed to true. Basically, we are forcing the system to think that AMSI did not properly set up. Now, if we execute this and we try once again with our malicious payload in here, notice that now it does not complain, and it means that now, technically speaking, we can, for example, generate a shell, right? And for example, in this context, we would generate a shell with a command like this: invoke PowerShell TCP. We put the IP address of the attacker, and look down below, we have our shell. Now, this first line is gonna complain, but after that, we are actually gonna execute our code and be fine with it. So this is an example to showcase that in this case, AMSI has been successfully bypassed. Now, how does that work? Why does it even work, right? And how would you understand that such payload would work? Now, as I said, first things first, the payload that I just showcased does not work with modern versions of PowerShell. So this payload works with versions of PowerShell like PowerShell 5. However, if you install PowerShell 7, which here I have installed PowerShell 7 as a test, if you try to do the same thing, so let's just clear this out, whatever. So let's just clear this out. Let's try the same payload. So notice, without the payload here, the reverse shell is blocked. Now, if you use the payload, notice that the payload failed because it says you cannot call a method on a null valued expression. And the problem in this context is that we are able to get the reference to the AMSI class, to the AMSI util class. So we do get the AMSI thing here, the system object. However, we are not able to get the reference to the AMSI init failed field. So the reflection capabilities in this case are limited. And why are they limited? Because this field is set to a way that is static and that cannot be modified after it has been initialized by the system. So in modern versions of PowerShell, they made it much harder to use reflection in order to bypass AMSI. However, there are also payloads that work for the modern versions, and I will show one at the end of the video. So, but the first thing, what I want to tell you, however, which is most important, is how do you even understand how to work with AMSI and how to bypass AMSI, right? Because that is the question. Now, any payload, any specific payload that today works, tomorrow might be fixed by Microsoft. However, if you understand how to reason about it, if you understand how to get into the details, into the internals of AMSI, you will be able to figure out your own payloads in the future, hopefully, right? So what could be some tools that would allow you to understand these things? Well, here I have two tools. Now, first things first, the DLL which contains the AMSI util class is this one. Is the system.management.automation DLL. And if you want to understand it, if you want to reverse engineering it, we can use the tool dnspy. This is a very useful tool. You can download it from GitHub. You can just go into the releases and download it. So for example, here I would go into the, let's see here, I will go into the dnspy GitHub. Now technically the project has been archived, but you can download the latest releases and they will work with the .NET versions. So look at this, you go to releases, this is from 2020. You go to releases and then you just download them for your system. So in this case I downloaded the DNSPY NetWin64, right? Then you double click on the executable and it works. Now in this case I've already loaded the system management automation, but if I didn't, I would just have to go and say open. And here in this dialog prompt, here in the path, I will put the path that I've got from this command. So from this command, I will put this path here, I will put it here, I will paste it here, and then I will just click on the system.management.automation DLL. Now, when it opens this DLL, notice here that we have a bunch of different namespaces, right? The one we're interested in is the system.management.automation, and here internally we have different classes. The class we are interested in is the AMSI utils class, okay? Now, this class has a bunch of properties and of methods here. For example, we have the init method. Now, as you can see here, the basic thing is that here we have some logic. It's not even that hard. So in the init here, we have some logic. And then at the end, we find this call to the AMSI initialize. And this call is made to the AMSI native methods, to this subclass of the AMSI utils. Now, these AMSI native methods here, it just implements the signatures for these functions. So these functions are the ones that actually interact with AMSI. And as you can see here, they are all taken from a specific DLL, which is the AMSI.dll. So here we have the AMSI initialize, uninitialize, open session, close session, scan buffer, and scan string, okay? And then here we have a enum of AMSI results. Now, by doing this kind of reverse engineering, you will be able to figure out how AMSI works. However, remember that this is not the AMSI DLL. The AMSI utils contains the sort of like runtime stuff that is needed by PowerShell to interact with AMSI, okay? So this is just a start. However, remember the previous payload that I showcased, right? The basic one, that one that works for PowerShell 5. Now this one, this payload, after all, what does it do? Well, it goes and checks the AMSI init failed field, okay? We can see this field in here, AMSI, let's see, init failed. It is a Boolean field which is initialized to false. Now, why is this interesting? Well, if we go into the scan content method here, look at this. Here it returns an AMSI result. It takes a content and it takes some metadata over the content. And so what does it do? Well, here we can see the logic. For example, here we have this hard-coded string. And if this hard-coded string matches, we give the AMSI result detected. Now, this hard-coded string is a test file, the so-called ICAR antivirus test file, which is used to to test out antivirus products. So it's really not that important. Then look at this. If the AMSI init failed, if this value is true, if this field is true, we're gonna return immediately AMSI result not detected. Okay? So consider this. Whenever we try to scan for something, if you're able to trigger this early return, we don't even perform the scan itself. So it is a very easy way to bypass the scan. Now, if we don't do this, instead we're going forward, and at some point in this logic, we're gonna open the AMSI session, and then at the end we're gonna do the AMSI scan buffer, which is where the AMSI layer will interact with the underlying antivirus engines, right? And they will detect the malicious payload. However, this is the entire trick of this simple bypass. We just trigger this early return, okay? So that's the idea. Of course, as I said, this thing cannot really be done in modern version of AMSI. Because remember, this should be private, static, and read-only. So there is no way in which we should be able to modify this thing after it has been set by the program itself. However, with the reflection capabilities of PowerShell, we're able to do that, at least for PowerShell 5. Now, given that the payload showed does not work with PowerShell 7, what can we do instead? Well, here the idea is to not use the NSPY, but rather to use a debugger like x64dbg. So how would we do that? Well, here we would open a debugger, we would attach to a process. Now here we have a bunch of different processes, but remember, we're not interested in the terminal, because the terminal is the graphical thingy. What we're interested in instead is the PowerShell process. So in this case, it will be the PWSH. So we attach to this. Notice now that we are running within that particular process, and we're interested in AMSI, right? So we go into the symbols tab in here, right here where there is symbols, as you can see there, and we want to look for the AMSI DLL. So here on the search button we write AMSI DLL, and look at this. So we write it here, and look at this, it filters to find the AMSI DLL, and it also gives us the base address over which it was loaded, right? And then within the method, of course, we are interested into the scan buffer. So here we write AMSI scan buffer, okay? We double click on it, and now look at this, it has brought us in the code where the AMSI scan buffer is actually implemented. Now at this point, we can debug with a breakpoint, so we can say breakpoints, let's put F2. With F2, we put a breakpoint. We're gonna just continue the process basically, right? We're just gonna continue the process. So let's do run. So we do run. At this point, we're able to write stuff here, right? So wait, let's do run again. Okay, let's do run. Okay, now we can write the process, perfect. Now let's say that we copy this thing and we send enter. Now notice that we stop the execution at the time of the AMSI scan buffer, okay? And at this time now, what we will need to do is we will need to read exactly all the different lines that are gonna be executed, basically. We're gonna read these lines, we're gonna see how the registers are modified, how the memory is modified, and this will give us more insights into how to potentially bypass this. Okay, now I'm not gonna do it in this video, however, I do want to share a resource with you, which is basically an article that I found, and it is this one. I'm gonna give it to you right now. So it is this article, it is by OffSec here, by the author Victor Khoury, Vixx. Very interesting article. Now in this article he showcases a way in which he found a vulnerability exactly as I've discussed. So if you're interested, go and read the article. Maybe in the future, if you want, I can do some more deep dives into the methods. But basically the way we use his exploit is pretty simple, which is a cool thing. So how would we do it? Well, let's close here the debugger, let's close this the process, and let's open a new Windows 7, right? We open a new Windows 7. Now, at this point, if we just do this, we're gonna get blocked, right? However, the bypass itself works by downloading 3 different files, right? Which is called a load.1 here from the GitHub repo, a load.2, and a load.3. Okay, so once we load all these 3 files, we call the method magic bypass, and then we just have to wait. We have to wait a little bit because this bypass is not too trivial, and it works by modifying the memory. So it has to search, it has to go through the address space, it has to do some searching. It's not immediate. However, in 1-2 minutes, it's gonna be over and it's gonna be exploited, and we're gonna be able to once again execute the reverse shell. So now I'm gonna stop the recording. I'm gonna start it when it right after it's over. Okay, so after 158 seconds we got our results. So let's test it out in practice. So after the bypass, I will try to execute the reverse shell, and notice it does not complain anymore. So let's actually get this reverse shell, right? Let's create the listener and let's trigger the reverse shell. And look at this, here I have my shell, I'm gonna do ID, it's gonna complain first, when I do ID again, okay, actually ID does not exist, so let's do UMI, let's do host name, let's do ls, and here I have all the different things in my user QuickEmu directory. So basically it does work, and we were able to bypass the AMSI. And if you're interested in the details, I suggest you to go and read the blog post. If you want to see more how it works more in detail, let me know and I will prepare more in-depth material. Of course, I thank the author of this blog post, Victor, for having done this research. Very, very interesting. Thank you. So this was the video itself. So in this video we showcase AMSI, we showcase a simple payload, and I discuss 2 different ways in which you can go into the depth of AMSI by using DNSPY to do reverse engineering over the DLL that triggers AMSI, and then AMSI itself we have to debug it with a debugger. Okay, so that is the idea. Now if you have more questions on the matter, more things that you want to see on this context, let me know and I will prepare material on the matter. Thank you very much. If you want to support me, if you want to support my work, there is a Patreon, and recently I've also started in a preparation group for the OSCP certification. Like details in the Patreon link below in the description. Thank you very much, and to the next video.